Hello everyone, in this video we'll be solving problem 14, longest common prefix. The problem statement is, write a function to find the longest common prefix string amongst an array of strings. A prefix is a substring or the entire string which starts from the first character of the string. So if we take the input as flower, its prefix could be F, FL or the entire string, but it should start from the first character. Looking at example number 1, where we have the inputs as flower, flow and fly, the common prefix is going to be F and L as it appears in all the three strings. In example number 2, there are no prefix characters amongst all the input strings that are common. Hence the output is an empty string. Let's switch to whiteboard and discuss a couple of approaches, starting with the brute force approach and then thinking about how we can optimize it. In the brute force approach, we'll run multiple iterations where we'll compare the characters in first string against the remaining strings in the array and continue the comparison until the values are equal. If at any given point of time the values do not match, we'll stop the iteration, save the results that we have accumulated so far and move on to the next string in the array. Let's do a couple of simulations to understand this approach a bit better. Let's call our pointers I and j, where I will always be pointing at the first string in the array and j will be pointing at the remaining strings as we iterate further. So s1 will be match, and with j pointing at the first index, the s2 will be matrix. We'll use the third pointer k to point at the characters in s1 and s2. We'll compare the corresponding values and check if the values are equal. If they are equal, it means it has a common prefix, so we'll save it in a different variable. Let's call it results. With k is equal to 0, both strings s1 and s2 have m at that position, so we'll add it to the result variable and increment the k pointer. With k is equal to 1, the corresponding characters are a and a in s1 and s2. As they are equal, we'll append it to the results variable and continue the iteration. Now with k is equal to 2, the corresponding character is t in both s1 and s2. As they are equal, we'll add it to the results variable. With k is equal to 3, the corresponding character in s1 is c, while in s2 is r. As they are not equal, we'll stop the iteration and save the results variable. Now we'll increment the j pointer and do the same operation with the next entry in the array, that is mattress. But for this run, we don't need to compare all of the characters with the first string. Instead, we'll do it with the results variable. As results variable already have the longest common prefix between s1 and s2 or the first and the second string, we'll take that result and comparing it with the s3. We'll repeat the same operation of figuring out the longest prefix between result and the next string, and whatever is the output will be saved back to the results, which will be used to compare with the next strings in the array. This operation will continue until we have iterated through all of the strings in the given array. At the end, whatever is saved in the results variable will be returned as the output. With this solution, our time complexity is O of s, where s is the number of characters across all of the strings in the given array, and the space complexity is O of 1, as we are not creating any additional collection to do the calculation. Now let's brainstorm a different approach to solve this problem with a better time complexity. Another way to solve this problem is by sorting the input array and then comparing the first and the last string in the sorted array. The rationale is that when we apply sorting to an array of strings, the character comparison starts from the leftmost and moves towards the rightmost. Because we want to find out the longest common prefix across all the strings, we can compare the first entry with the last entry of the sorted array to see how many characters are equal. The remaining strings in the sorted array in between will also have the same longest common prefix that we calculate between the first and the last string. Let's apply the logic to this input and confirm if it will work or not. After sorting, the input array will look something like this. Now let's compare the first and the last entry in the sorted array, which is mat and mattress. Between the two strings, the common prefix is mat. We don't need to programmatically check if this string mat is also a prefix for the remaining strings in the center, but we can still look at the sorted array and confirm. Let's add one more string mic to the input array. Post sorting, mic will be the last entry in the sorted array. Now if we compare the first and the last, that is mat and mic, the common prefix will be m, which will be our output. With this solution, our time complexity is O of n log n because we are sorting the algorithm. So this time complexity is for sorting, and the space complexity is O of 1 as we are not creating any additional collection for comparison. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by checking if the length of the input array is greater than 1. If it is, then I'm sorting it. Then I'm creating two variables, one pointing to the first entry in the sorted array and the other being at the last. I then start a for loop from I is equal to 0 until first dot length or last dot length, whichever is smaller. This is to avoid getting index out of bound errors. We then check the character at I in both first and the last string, are they equal? If they are not equal, we stop the iteration and return the results variable. And if they are equal, I append the corresponding character to the results variable and continue the iteration. If the length of the input array is 1, then we return the first entry in the array. And if there are no entries in the array, we return null. This code, when submitted on LeetCode, meets 90% of the submissions in terms of runtime and 51% in terms of memory consumption. Thank you for watching this video. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.